Hello everyone, are you curious or do you want to understand how to write the dimensional equations of a physical quantities? Your worries are over. Before we start the process, please hit the like button and also subscribe on our YouTube channel Supercell Academy is Go 5. Now let's move on to the main theme. Hi friends, there is physics, but we are going to discuss the dimensional of physical quantities. As you can see the definition, it is a relation that connects between physical quantity and fundamental quantities. You know, physics acknowledges 7 main fundamental quantities, but out of those 7, they only choose 3 to express this physical quantity in terms of its dimension. For instance, mass is m, for length is L, time is capital T. So now they ask us to write the dimension equation. So this dimension equation is an equation which expresses physical quantity in terms of its dimension. So let's go for the first one, speed. Speed, the formula here is distance over time. In order for you to write the dimension equation for any physical quantity, you must know their formulas. So speed is distance upon time. Mind you, distance is measured in what? Meter. So we say distance is the same as length all over time. So the dimension for length is capital L, for time is what? Capital T. So L times 1 upon T. So L, so the negative index for this 1 upon T is what? LT raised to the power minus 1. So we go for 2, which is area. Area, the formula is equal to length times breadth. So length times, mind the breadth, it is not part of what? The choosing dimensions. Are we getting it? But breadth measure in what? In meter, which is under what? Length. So you say length. So the dimension for length is capital L, this also capital L. So when you multiply this, it will give you what? L raised to the power 2. You can use your law of indices. This has a power of 1, this also has a power of 1. You can say L raised to the power 1 times L raised to the power 1. You take 1, you add the power. So 1 plus 1 is to give you what? 2. Then we go for 3. Velocity. Velocity, the formula for velocity is displacement all over time. But when you look at these 3 dimensions, displacement is not part of them. But displacement measured in what? Meter, which is what? Length. So length all upon time. The dimension for length is capital L. Time is what? T equals to LT raised to the power minus 1. This has a power of 1. Are we getting it? So if you observe speed and velocity, they have the same dimension. So the next one is acceleration, right? Acceleration, the formula for acceleration is equal to velocity all upon time. But velocity, its dimension is what? LT raised to the power minus 1. So you say LT raised to the power minus 1 all over what? T. So LT raised to the power minus 1 divided by T. This has a power of 1. So they have the same base. So what we need to do, we use the division law of indices. We take 1 of the t, we subtract the power. So minus 1, say minus 1, it will give us lt raised to the power minus 2. So acceleration is lt raised to the power minus 2. So we go for 5. 5 says force. Force is equal to mass times acceleration. So mass times the dimension for acceleration is lt raised to the power minus 2, while for mass is capital M times lt raised to the power minus 2. So the dimension equation for force is m lt raised to the power minus 2. Then we go for work, which is 6. Work is the product of force times distance. So the dimension for force here is m lt raised to the power minus 2. Mind the distance, it is not part of this, but distance measured in what? In meter. So it is under what? Length. So you say capital L. But here you say m times L times L. Correct like terms times t raised to the power minus 2. So L times L will give us what? L squared. So you write t raised to the power minus 2. So the dimension for work is m L raised to the power 2 times t raised to the power minus 2. Then we go for momentum. Momentum is equal to mass times velocity. The dimension for mass, mind you, mass is under. Dimension for mass is capital M. While for velocity, the dimensional equation for velocity is what? lt raised to the power minus 2. Sorry, minus 1. Are we getting it? Some of them, some people or some students, they may just make use of the opportunity and say the dimensional equation for velocity is capital V. No, don't take that concept. The dimensional equation for velocity is what? lt raised to the power minus 2. So when you multiply, it will give us mlt raised to the power minus 1. Example 8, which is what? Pressure. The formula for pressure is force all upon what? Area. But the dimension for force, don't say capital F. Mind you, we have written what? The dimensional equation for what? For force, which is what? mlt raised to the power minus 2. Yes, look at it here. So you say mlt raised to the power minus 2. While for area, mind the formula for area is what? Length times breadth. So the dimension for area is L raised to the power 2. So you say mlt raised to the power minus 2 all divided by L times L. This cancels with this, right? So you take M, we want to take this L up. So division law of indices. So the inverse for this is what? L minus 1, that is L raised to the power minus 1 times t raised to the power minus 2. So we'll go for power. When you say power is the rate of doing work. So it's work upon time. So the dimensional equation for work is what? M L raised to the power 2 times t raised to the power minus 2. Don't say capital W. If you say that, you're out of what? The concept, right? But the dimension for work is ml raised to the power 2 times t raised to the power minus 2, all divided by dimension for time is what? T. Do we get it? So you say ml raised to the power 2 times, mind you, this has a power of 1. So this and this, they have the same base. So just take one of the base and what? Subtract the powers. Are we getting it? So minus 2 minus 1. So ml square, say t raised to the power minus 3. So the dimensional equation for power is ml square t raised to the power minus 3. So please subscribe on our YouTube channel Super Star Academy Go 5 and also hit the bell like button.